In today's lesson, we are going to be looking at applications of right-angled trigonometry. So we're going to be taking the two lessons that we looked at over the last 2 days, and we are going to be applying those concepts to some real-world scenarios or to some more practical applications. So some things we want to be mindful of, or some tips we want to make sure we're following when we're dealing with these types of word problems or scenarios, is we want to again make sure that we label the hypotenuse, opposite, and adjacent. And those are the three sides of our right angle triangle, and we want to make sure that we label them properly because that will be important for figuring out what ratio to use. Right. We then are going to use SOHCAHTOA to determine what trig ratios you can use. Remember, look at the sides that we're dealing with and then determine which ratio deals with those two sides. We then had a summary of, depending on what we're looking for. If we're looking for a missing side, there's two options, right? Either the missing piece is on the bottom, in which case our process is we're going to end up switching and dividing, or the missing piece is on top, which means we would bring up and multiply. Right? So that was kind of a summary of the process to solving from a missing side. And when we're trying to find an angle, we use the inverse function. Aside from those tips, what we looked at from the previous lessons, there are going to be two scenarios that you might come across that the word problem or the scenario might have that basically just gives a description to what the scenario is, and so it gives us a little bit more information. One is the angle of elevation. And what the angle of elevation is, it's the angle between the horizontal and the line of sight when looking up at an object. So if I look at this diagram here, we see our horizontal line represented by the black dotted line. That is our horizontal line for our eyesight. The angle of elevation is then measured from that horizontal upwards until we reach our line of sight, represented by the blue line here. So that angle in red is our angle of elevation. So from horizontal and up. On the flip side, aside from the angle of elevation, we have the angle of depression. And the angle of depression is the same thing, or kind of very similar to the angle of elevation, except instead of looking up from the horizontal, we are looking down from the horizontal. So again, looking at our diagram, we have our dotted line representing our horizontal. The angle of depression then measures from that horizontal line and down to our line of sight. So again, angle of depression is down, angle of elevation is up. So those are phrases that you might see in the scenarios that kind of gives us more information to the problem or the scenario. So let's look at our first example. So Mr. Liu, who is 1.9 meters tall, sees his cat stuck in a tree. The angle of elevation of my line of sight to his cat, or to my cat, is 54 degrees. If he is standing 5 meters away from the tree, how high is his cat? So I'm going to draw this scenario out so we have an idea of what it's going to look like. So if I'm standing, I am standing a certain distance, so I'm going to draw just a quick figure, nothing fancy. So I know that I am 5 meters away from a tree. My tree. From my line of sight, there's an angle of elevation of 54 degrees, and my line of sight is going to my cat who is stuck in the tree. I'm going to draw in the horizontal here so we have a good understanding of where this angle of elevation is actually occurring, because it's not going to be from the bottom, it's going to be from my line of sight. Then we have our angle of elevation upwards from that line of sight. Now I'm going to put in the information from our question. Right? I'm going to use that to help label. I already have the 5 meters for how far away I'm standing from the tree. I am 1.9 meters tall, so that is going to be my height. So I'm just going to put that off to the side to show that I am 1.9 meters tall. The angle of elevation, we have mentioned 54 degrees. Again, that's angle of elevation, so that's going from the horizontal up to my line of sight. So in this case, we said 54 degrees. And the question is asking how high is the cat? And the cat, we're just going to draw a small little cat up here. So there's the cat up in the tree. So I want to figure out how tall or how high up is the cat. So I'm trying to figure out this total measurement. Now looking at this, hopefully we see where there could be a triangle or a right angle triangle involved in our scenario. And that would be the triangle between my eyesight, the horizontal, and the cat. So I'm going to draw that separately. So if I draw it separately, I have 54 degrees here. I have my right angle here. And because I'm 5 meters away, that also applies to where my eyesight is. So if it's 5 meters down here on the ground away from the tree, it's also going to be 5 meters up here from my eyesight, or from my eyes, you could say, to the tree. It's going to be 5 meters as well. So here we now have our triangle. From this triangle, now we have something very similar to what we looked at the last couple days. I want to label my sides. So I have my reference angle here. I have my right angle. Across from my right angle should be the hypotenuse. I have my only angle here as my reference angle. So across from that is the opposite, and that leaves the adjacent as the side that's 5 meters. Now I've labeled my sides. I need to figure out what ratio to use. So what sides are we dealing with? Well, we have to be dealing with our adjacent because we have that, or that's the only side that has information. I am also looking for the height of the tree, so I should be dealing with the opposite because that represents part of the vertical line, or part of the height of the tree. So I'm going to be dealing with O and A. That means O and A, the ratio is the tangent ratio, or tan ratio. I'm going to write out the ratio. Tan theta equals opposite over adjacent. And I'm going to plug in my information. So I know tan of the angle, tan of 54, is equal to the opposite. We don't know, so I'm going to leave that as, we'll put x in there as a placeholder. And then the adjacent is 5. So this is a scenario where the missing piece is on the bottom. Because the missing piece is on the bottom, that means we bring up and we multiply. So we have 5 times tan 54, which will then be equal to x. And on our calculator, if we go through and calculate it, 5 times tan 54 is 6.88. So that is the height of this vertical part. Now, is that the height of the tree? Now, some of you might be inclined to say, yes, that is the height of the tree. It's the vertical part. However, we have to keep in mind that we're looking from my line of sight. And my line of sight isn't at the bottom. My line of sight is, as we kind of have it over here, my line of sight is not 1.9 meters in the air or above the ground because I'm 1.9 meters tall. So what we need to do is, for the actual height of the cat, we need to call it height is equal to 1.9 plus the 6.88 that we calculated. Because we only figured out, with using the right angle trig, we've only figured out this portion of the tree. We need to figure out what the entire height is. So that's why we're adding the two heights together. So 1.9 plus 6.88 is 8.78. So that is the actual height or how high the cat is. So a little bit of a two-part question or two-step question. Example number 2, a missile is launched at an angle of elevation of 80 degrees. If it travels in a straight line, what is its altitude when it hits the training drone 15 kilometers downrange? So we're going to draw a missile. See, test our art skills here. So we're going to draw our missile. There's our missile. It's getting launched at an angle of elevation of 80 degrees, so we can assume that it is on the ground. It is being measured at 80 degrees, and it's going to fly in a straight line until it hits our training drone. So let's draw a quick training drone. And we want to figure out how high that training drone is if we know how far downrange it is. So we know it's 15 kilometers downrange, so that is going to be our horizontal. And we are asked to find the altitude. Altitude is another word for the height. So I'm looking for that measurement. So here, again, nothing too tricky. We can hopefully see the right angle triangle that we're going to be dealing with. And let's go through and label it. Across from the right angle is the hypotenuse. Across from the reference angle is our opposite. And the side beside it is the adjacent. Looking at what sides we're going to be dealing with, we are looking for the opposite and we are given the adjacent. So we're going to be using O and A. And again, O and A refers to our tan ratio. So we're going to write out our tan ratio. Tan theta equals the opposite over adjacent. Very similar to the last example we just did. We're going to plug in information that we know. So tan of 80 or tan 80 is equal to an unknown value, x, divided by 15. Again, because the missing piece is on top, we bring the bottom up and we multiply. So we have 15 times tan 80 will equal our unknown height. This is now just a calculation, and we get 85. Yeah, we'll round to 85. So 85 kilometers is equal to x. So that means that this drone is 85 kilometers in the air, right? So pretty high. But again, with this one, there's nothing extra that we need to do because it's assumed that the rocket is on the ground. Now, if you have questions about this, or you're not 100% sure about where the rocket is, should we be adding a height in, right? If you're ever unsure about that, make sure you're asking, because this will be sometimes a little bit difficult to determine. And yes, obviously, it might not be as detailed and specific as it maybe could be. So we do have to make some assumptions in some of these questions. Last example, multi-part example with these. So a hot air balloon on the end of a taut 95-meter rope rises from its platform. Sam, who is in the basket, estimates the angle of depression to the rope is 50 degrees. First, we want to figure out how far did the balloon drift horizontally. So if we have a platform, being very finicky. So if we have our platform, and on this platform we have our rope, and we tie it to our balloon, and the balloon drifts away. So we have our hot air balloon here. Move this down a bit. So this is where some of your art skills can come into play, some of your creativity, if you want to draw a nice picture. So there we have our hot air balloon tethered to its platform. We know that the balloon is 95 meters, or the rope is 95 meters long, and Sam, who's in the basket, estimates that the angle of depression to the rope is 50 degrees. So because an angle of depression is a downwards angle, we should be looking from a horizontal, which we'll draw in a dotted line. So we have our horizontal from where Sam would be in the basket, and the angle of depression is going to be downwards towards our line of sight. So Sam's in the basket, then the horizontal looking down for angle of depression is 50 degrees. So we have the angle of depression labeled, we have 50 degrees, we have the 95 meters for the rope, and the first question asks how far away horizontally did the balloon drift? So we are looking for this measurement here. We want to find out what is this horizontal length. Now, we kind of draw in our 90 degrees, right? We can see kind of the horizontal and the vertical component of, or the height of the balloon from the triangle or from the platform. It forms kind of like upside down right angle triangle here. I'm just going to draw it slightly or just small over here just so we have an idea, so we focus specifically on it and not just the drawing. So we have 50 degrees, 95 meters, and we're looking for that measurement. Again, now that we've drawn it, we want to label our sides. Across from 90 degrees is the hypotenuse. Across from our reference angle is the opposite, and that leaves the adjacent as the last side. Here, we're looking for the adjacent. We're given the hypotenuse, so we are using A and H. So this is going to be a cosine ratio. So cosine of our angle is equal to the adjacent over the hypotenuse, A over H. I'm going to plug in my information. So cosine 50 is equal to, make it look like an S and not a 5. So cosine 50 is equal to an unknown value over 95. Because our missing piece is on top, we're going to bring up and multiply. So 95 times cosine 50 equals X. And if we go through and plug that in our calculator, 95 times cosine 50, we get 61.1 is our horizontal distance. So that means that the balloon drifted horizontally 61.1 meters. B is now asking how high is the balloon off the ground? Now, if we want, we can go back and we can use the exact same triangle. Oops. I didn't know I could do that to make straight lines. Oops. Oh. Things you're learning when you're kind of just playing around or pressing things and you're not sure. So there I have my triangle. I'm going to redraw the exact same one, 50 degrees, 95. I'm going to label it the exact same way because I'm still using the same angle. So the opposite, the adjacent, the hypotenuse. The only thing that's going to be different in this one is because now the question is asking for how high is the balloon off the ground. So we are going to be looking for this or X or our vertical component or this vertical line here. So this is going, even though it's the same triangle, I'm going to be using a different ratio because I'm dealing with different sides. Because I'm dealing with O and H, I'm going to be dealing with the sine ratio. So sine theta equals opposite over hypotenuse. I know it's going to be 50 degrees. I don't know the opposite. I know the hypotenuse is 95 still. So even though it's a different ratio, I'm still missing the piece on top. So that means I bring up the bottom and I multiply. Very similar to the last question, just a different ratio. So 95 times sine 50 equals our unknown. This just becomes a calculation. And we get 72.8 meters is the height. And the very last question, viewed from the platform, the angle of elevation is what? So again, I'm going to draw the full scenario out here because it's going to be it's going to be helpful. So I have the angle or the line of sight. It goes to the balloon. This drawing is going to be a little bit quicker. It goes to the balloon. We know that from the horizontal down, this angle of depression is 50 degrees. And we want to figure out the angle of elevation on the platform. So the angle of elevation on the platform goes from a horizontal. So if I look at the platform and I have my horizontal and I go up from that horizontal, this is the angle of elevation that we're looking for. Now there's different ways you could go through and solve this. You could, if you wanted to, you could draw out the triangle that we've been dealing with. We know that this is 50, this is 90, this angle here is unknown, and we're looking for this angle here. So we could do 180 minus 90 minus 50. We would get 30. Nope, not 30. We would get 60. So that angle on the inside of the triangle would be 60. And then for this actual angle that we're looking for, this angle of elevation from the horizontal up, we would do 90. Again, assuming that the vertical and the horizontal make 90 degrees. 90 minus 60, which would make this. Did I do that? No, I'm not doing that right. That should be 40. 90 minus 40. And that would make this 50 degrees. So that means the angle of elevation would be the exact same thing as the angle of depression from what we were looking at. The other thing that we could do, we could look at our diagram here and realize, well, I have a horizontal on the bottom, horizontal on the top. Two horizontal lines are going to be parallel. I can go back to grade 9 and use my Z pattern to determine that this angle in here should be 50 degrees. So different ways you could go about solving it. Either way, we determine that the angle of elevation is 50 degrees. Right, so just different ways we could think of the triangle, different pieces of information that we can find based on what we're given. Right, so again, all we're doing is just taking the right angle trig concepts from the last couple days, combining them into word problems using some new vocabulary that we might come across in some of these scenarios that gives us kind of more detail to what we're looking at. So again, make sure you are reviewing the previous lessons. Make sure you're comfortable using right angle trig because it is obviously important when you're working with these application questions. Make sure you're looking at the tips to make sure you're kind of going through it step by step so that you can help figure out the answer.